So we will do some problems from 8.5, which is probability. Again, very important. Let's start with problem 3. So f of x is given to us. So f of x is known as well, it is some function, but in this, it's f of x will stand for a probability density function. So let me write what is given. So function like this is given to us. Now the question is, we have to verify that f is a probability density function. So not every function can be a probability density function. It has some special properties. So probability density function is 1. It satisfies two properties. That f of x is greater than 0 for all x. And the second property is, so f of x should be positive or greater than equal to 0. And the second is that the total probability should be equal to 1. So if the given function satisfies these two properties, we can say it is a probability density function. So the first property is easy to see, that f of x is always positive. So for the first property, we see that f of x is greater than 0 when x is greater than 0. Why? Because this function over here is always positive when x is positive. So I can change it back to infinity if I want to. But then infinity will be, so let's keep it 1. So x squared is always positive, and this term in parentheses is also always positive. And if x is equal to 0 for all other x. Right. So if x is 0 when x does not lie in this interval, and is 0 when x is equal to 0. So the first property is satisfied. Now we have to check the second one. Now, although here you see infinities, and you may wonder that every time it's an improper integral, but that's not the case, because most of the density functions will be 0 for some values of x and will be non-zero only in some finite region. So we only have to take the antiderivative in that finite region where the density function is non-zero. So it may look like an improper integral, but most of the time it's a proper definite integral. So if this integral equals 1, then it's a probability density function. Let's calculate it. This is now simple power rule. And this 2 can cancel the 4 here. And if we take the common denominator, that turns out to be 30. And here we get 10 plus 6 minus 15. So you have 16 minus 15, 1, and this 30 cancels out. So this is equal to 1. So it means the given density function is a probability density function. So we have checked this condition. Let's do next homework problem. Very important. Number 5. So here f of x is given to be some constant c over 1 plus x squared. And the part A is for what value of c is f a probability density function. So part A, find c such that fx is probability density function. So now we have to find C such that F is a probability density function. So the first thing you see, we again have to satisfy the two properties that we discussed above, right? These two properties. So this is the first property, and this is the second property. So the first property, that fx is greater than equal to 0. So we see that C has to be positive. So to satisfy first property, C is greater than 0. Or we can say greater than equal to 0, but if C is equal to 0, then F is 0. Now in order to satisfy the second property, we have to find C such that so we have to solve for C. And you can note that this is an improper integral. So we have to solve this improper integral and equate it equal to 1 and then find C. Let's do that. So you can see there are two infinities. So the first step is to break this improper integrals into the sum of two improper integrals. So this is the equation we are solving for C. Next is a very important step. We have to change it into limit definition. Now, if you remember the antiderivative rule, so C is constant, and we have dx over 1 plus x squared. So if you remember this, is your arctan or tan inverse. Now what is tan inverse 0? This is 0. So tan inverse 0 is 0. And as t tends to negative infinity, tan inverse negative infinity is negative pi over 2. So we get negative pi over 2, and tan inverse infinity is pi over 2. And all this is multiplied by c. Right? So this means c times pi equals 1, or c equals 1 over pi. So if c equals 1 over pi, then the given function is a probability density function. So c we have found to be 1 over pi. And that's part B. For what value of c? For that value of c, find the probability. So now we have to compute the probability that x lies between negative 1 and 1. So this probability is given by negative 1 to 1. So we have to solve this definite integral from negative 1 to 1. So these serve as the bound of the integration. Right? 1 over pi c. tan inverse 1 is pi over 4. Tan inverse negative 1 is negative pi over 4. So this probability is half. So here, the important thing to keep in mind is we have to solve an improper integral. So this is the improper integral we have to solve. So if you are careless, you will skip this step and you will lose a lot of points. So this is the important part. And this is an improper integral. Let's do next problem. Number 11. An online retailer has determined that the average time for credit card transactions to be electronically approved is 1.6 seconds. So it says average time 1.6 seconds. Let's call this average as mu. Part A is use an exponential density function to find the probability that a customer waits less than a second for credit card approval. Now we have to use an exponential density function. So for this, you should know what is an exponential density function. So this mu is given to us, and this serves as the parameter for exponential density function. So if I want to write down exponential density function, so this is the exponential density function. You can see the presence of exponential function. The variable, the random variable is t, and the expectation value or average value mu is 1 over mu here, and it's negative t over mu. Important thing that you have a minus sign and you have mu in the denominator. So don't forget this. So we have to use this function to compute the probability t less than 1. So less than 1 is time is always positive, so lower bound is 0. So here I'm using mu as 1.6, which is given to us. So I'm using this given value of mu. over here. Now this antiderivative becomes so I'm writing fraction for 1.6. So here I have written 1.6 as 8 over 5. So I like to work with fractions. You can keep the decimal, it's up to you. Both are correct. So this is your final answer. You can leave it like this, or you can use your calculator to determine that this equals about 46.4%. And this comes from a simple antiderivative rule. If it confuses you, you should try use substitution, this whole thing, and you will get a factor. And then let's do next part. Find the probability that a customer waits more than 3 seconds. So now we have to find that t is more than 3 seconds. More than 3 means you start from 3, you can go up till infinity. Now here, although this is an improper integral, but you can just write that and you can say that this term goes to 0. So this term goes to 0 as t goes to infinity. So in this exponential and a variable case, you don't have to do this improper integral every time. But writing this thing is very important. So then your answer becomes and in decimal form it is 15.3%. But this is also correct. You can leave it like that also. Now, part C is a different type of question. Here, what is the minimum approval time for the slowest 5% of transaction? So minimum time for slowest 5%. So here probability is given. And we have to find the time. So it's the reverse question. So we have to solve an equation of type. So what is this capital T such that the probability is 5%? So 5% means 0.05, which in fraction form means 1/20. So we have to solve for this time. So the answer is given to us. It should be 5%. But it's a reverse question. We have to find for what value of t such type of probability will equal to 5% or 1/20. So we proceed the same way. Just like above part. Like here you see. When t is greater than 3, the answer comes out to be -3/1.6. Or e to the power -3/1.6, which is 15/8. So we just replace this 3, which was here, by capital T. This then answer is now we have to solve this equation. So whenever we are solving an exponential density function for t greater than some value, the answer will always be e to the negative that value over mean. And we found it here, like this. So now if you solve for this, how do we solve for this type of equation? You can take the log of both the sides. natural log. Because ln1 is 0. And if you use your calculator to compute ln20, you will get about 4.8 seconds, 4.8 minutes. Or seconds, sorry, not minutes. So this is a little confusing part, but it's more relevant for probability courses, so I don't expect it to come in the test, but still you know how to solve these integrals. But this exponential density function is very important, so you should keep that in mind. Let's do one more homework problem. It is number 30. So density function is given to us. So T over 1600. So here T is in minutes. And this is something REM sleep. You can read the problem. There is some theory, but the important point is this is the density function, and now we have to solve a couple of problems. So what is the probability that amount of this REM sleep is between 30 and 60 minutes? So the part A is so P is between 30 and 60. T is between 30 and 60. So you have to set up first. 30 and 60 will serve as the bounds of the integral. Then you can see between 30 and 60, it takes one value up till 40. And then from 40 to 80, it takes a different value. We have to break this up. Now it's simple antiderivative. So 40 square is 1600, was 4 square is 16, so 1600. Now this is just simple calculation. So 19 over 32 minutes. Not minutes, sorry. The probability is in always in percentage. So the in percent it becomes about 59.4%. So this derivative is 19 over 32 is equal to similar to 59.4. But you can leave your answer in fractions as well, unless the problem specifically says that you have to leave the answer in percentage, then you should leave it in percent, but leaving it up till here will also full credit. Now part B is an important problem which can come in your exam, in any exam, with any density function. So part B is you have to find the mean of this probability density of this random variable. So mean amount of RE and sleep. So mean means we have to find what is mu. And the formula here is for mu. So I'm using the general bounds, but we will switch to the bounds of the problem. T, so this is a new thing here, times your given density function. So this is very important. This means you're calculating the mean. So you multiply your density function with your random variable. It can be t or it can be x. And then do the antiderivative. So if you forget this, you will just get answer as 1. And that's wrong. That means it becomes, in our case, so from 0 to 40, this density function is t over 1600. And 40 to 80, this is given by this. And it's 0 otherwise. So to calculate mean, we'll multiply t to this term and to these terms, and then integrate over these intervals. This is again now simple antiderivative using power rule. So the setting up is the tricky part here in probability problems. Four cube is 64. Eight cube is 512. And 3 zeros because it's cube of 80. And 4 cube is 64. So you can use your calculators, and but this will give you, I'm cancelling with 16. So 16 times 3 is 48. And 16 times 4 is 0. So you get 40 over 3. Right. So 4 cancels 480 by 120. I'm first cancelling 2 zeros. And you can write it here. And do the same thing. 16 3 is 16, 40, 16 3 is 30 to 20. So 320 minus 40 is 280. This is a minus sign. So what we get is 120 minus 240 over 3. Is 40. So the average is 40 minutes. So the average we get here is 40 minutes. So this is just, I've spent some time in doing this algebra calculations just to show you that you can do it without calculators also and with calculators also. If you forget your calculator and it's not working, you can still finish the problem. So this finishes 8.5, and I have done 4 homework problems out of 5.